for today's session. Let's see, today is Tuesday, September 15. Admitting some more people. If you have a question, toss it in the chat here. Get some more people in. Trying to get more organized. So I am already recording, and you would have noticed that when you tried to join the session. Last session, I did not hit the record button and we had no recording. Now I posted the class notes. So I apologize for the screw up. This is now, the remainder of our sessions are now set to automatic recording, but that has its own extra buttons to press. So it shouldn't be too bad. I just got to get used to it, whichever way we choose to do it. So today we are looking at absolute value. Everything about absolute value. Equations, inequalities, which are the things we've been doing most recently. The compound inequalities are going to help us a lot today. And some special cases. There's some very particular rules to learn today, but I've got several sources for you to review while you're learning them. And if you have anything you'd like to work on in particular before we get started, you can throw it on the table. Just admit some more people here. As I get used to the button pressing and things like that, I might get everything opened up a few minutes before 12, but I'm still trying to figure out how to do everything efficiently. So you have to be patient with me for a little while. I want to first look at my website. We'll do that every day a little bit, and sometimes less and less as you get used to it, but I want to remind you of the homeworks that you're going to submit tomorrow, or by the end of the day tomorrow. So let me hop over there. So base website, now this is week 2. I was just looking at what we did last time we met. You can always press 119, you get our opening website. I wanted to point out something new to you on the opening website. I think I said this last time in class, but now I have a link for you. I know the lady who's running or organizing these facilitated study groups. So that might be useful to you. I know you have all kinds of crazy time constraints, and so do they. And so that's the time that they picked that could work for a lot of people. I apologize if it doesn't work for you, but you also have access to book videos, helps, and me if you need some extra help and you're available at that time. And you got to be patient with how people start and work things out, but I have confidence in the person who runs this facilitated study group material. So you might find it helpful. You can click on that link along with other tutoring services. Let's look at week 3. And you're going to get used to the format as you go along, the outline, what sections we're doing, some recommended problems, then homework, handouts, video, technology exams. I have, let's go from the bottom, technology. I'm going to show you some Desmos things today if I have a chance to get that in there. Maybe let me add it to my paper so I try not to forget, because that'll help you understand things. And it's related to your next homework written. So there's a little Desmos example right here that you might enjoy. Also related to absolute value, I've added some videos to our topics playlist. And these videos are going to reinforce the rules that we discussed today. I'm going to give you some very particular rules that you have to follow exactly. And it takes practice to follow them exactly. And if you don't follow them exactly, you get the wrong answer. There's no other way around it. But apart from just hearing the explanation once from me, you have the opportunity in the book to read and hear the videos. You can watch what we're doing today, but these are short 2 and 3 minute videos to help you see each of these rules one-on-one. So they're listed on the topics. They're the Math 119 topics. So that's just a playlist. And I've got a lot of things in this playlist, but you could click on the individual links for practicing absolute value from our website, and you could go to these directly. Do you see, okay, 3 minutes, 46 seconds, 3 minutes, 3 minutes, 3 minutes. Okay, they're all in the order of 3 minutes. But they would just walk you through the problem one step at a time. Kind of a tiny short lecture, if you like. So check out those videos, check out the videos that are associated with the book. And then I've got some other handouts organized here. The link to the study groups, tutoring center, honors program. Don Schmidt Award is an award given by the math department. I thought I'd say a word about that if I click on it. And this award is in honor of a colleague of ours who passed away. And she was very interested in all aspects of education, teaching, and mathematics, science. And so the math department established this award in her honor. And you can read through the criteria. It's kind of directed towards people who are considering teaching in math, but at the elementary, secondary, post-secondary level. If you have an interest in this, read this application. And if you have any questions about it in particular, feel free to send me a note. But it's open to students at every level. It's not meant to be only if you're taking the highest classes or only if you're just graduating. Okay, and then we've got the graph paper. Key points of graphs. I haven't mentioned this handout, and we will talk about it a little bit later as we go along. But this is just a very broad handout I made for this class for all kinds of pictures we're going to draw. And we haven't drawn very much at all. This week, we're going to draw line and absolute value graphs. But the reason I made this handout showing you these pictures, sometimes people have this impression when they're doing class like algebra class, intermediate algebra class, that graphing is a terrible thing. There's a million different graphs, and how do I find the points, and how do I know if it's right? All kinds of kind of anxiety-riddled questions. But I want to look at it from another perspective, and that is there might be a million graphs out there, but there are only a handful of shapes. And yes, I know that there's billions of lines, but every line has a particular shape and a particular pattern, even if it looks different than this line. And so my point on this handout is I'm giving you some famous shapes. And if you think in terms of shapes, instead of thinking in terms of individual problems, then you begin to transition from, oh, there's a billion shapes and I'll never learn them all, to, oh, there's a handful of shapes. And I just have to know the kinds of shapes I'm being told to draw. So, like I said, this week we'll be investigating line and absolute value shape. And then we'll move on to these other shapes as time goes by. And I'll come back to this sheet again and again. But I'm just giving you some examples of the basic shapes. Okay, next example. Under these handouts about lines, now this is not going to come into play until Thursday, so maybe I'll hold off clicking on these, but we're going to do lines left, right, up, down, 7 ways to Sunday. And here are some worksheets and answers that you could do if you want some practice. I know when you're doing a homework problem in the book, you always get this question like, did I do it right? How do I know if I did it right? Well, there's lots of ways we can check, but here I have problems where you're going to graph some lines that you could practice. And then right next to it, when I say solution, I drew all the lines. So you could look to see and compare it to your line, see how your line compares. Did you graph it correctly? So sometimes I do that, give you, here's a worksheet, here are the answers, here's a worksheet, here are the answers. You know, it's only going to be profitable to you if you try to do the problems and then look at the answers, not just if you read the answers. Reading the answers doesn't help you in any particular way. Handout about absolute value inequality. So I can't even remember what I put there. A little bit slow right here. It's amazing what you consider slow after you get used to things. We're used to having everything instantly. And, you know, there are some people, you know, maybe it's parents, maybe it's much older brothers or sisters. This is not coming. So let me go back there. And you know, what you say is slow, to them it looks miraculous. There's the handout. Okay. Sometimes I got handwritten handouts like this to just give you some examples of what we're saying and doing. So it's extra material. Use it if you want to. The more explanations you hear, the more valuable it is. This is not super duper important, but I'll just as far as things go, let me get out of this page. I mean, my degrees when I went to college were in mathematics and theoretical computer science. And I will just be honest and direct with you, and that was graduating in 1988. Everything I learned in graduate school about theoretical computer science, a computer science student would learn in their second year right now in college, a sophomore. On the other hand, I got this great benefit of watching things come true over 20, 30 years. Sometimes you watch things come true and it's scary. Sometimes you watch things come true and it's wonderful. We are recording it, yes. Thank you. I just want to confirm that. We recorded it from the very beginning. So when you entered, you probably had a notice that you were being recorded. So yeah, things seem slow to us if they take a few seconds nowadays. Okay, so those are the handouts. Let's make sure we're on the same page with the homework. You have a homework due tonight. I'm sorry, not tonight. Mixing classes due tomorrow night, 11:59. You have this written homework that you've had in your possession for about a week. Okay, we're gonna do this slow thing. And then you've got the XYZ homework from sections 2.4 and 2.5. Now you've done some XYZ homework already, and I'm compiling what you did there, and I'll give you grade reports and things like that, maybe later on at the end of this week, over the weekend. But this is the problem that you're preparing for today, just asking you some questions about evaluating these formulas. Bring those to our assignments Dropbox. You can submit them anytime. Some people have already submitted it by 11:59 tomorrow night. I'd like you to pay attention to two things. I want you to name them in a very particular way, and that's written on our syllabus under the expectations. I got a lot of papers people send me, and I just want you to keep them straight. You know, if you send me a paper with just your name on it, yeah, I remember what class you're in. I get to know you as time goes by, but it's a lot easier for me filing things if you write last name, first name, homework, class, like that. And here's another weird thing. Sounds strange, but it's really not helpful when you think about it. Sometimes you do exactly this and you give me this name on your file, but the paper that you took an image of does not have your name on it. So just pretend a disaster happened. I want to know whose paper that is because I want to give you the credit. So do write your name on your paper so that I don't have any absolute disasters. I'm asking you to submit these as PDF files. I'll help you get into that. And remember here, I gave you two programs that you can use, Apple Notes or Adobe Scan. Those are free programs you could use on a mobile phone. There are other programs you can use on computers or other devices. But don't just take a picture and send me the JPEG. Tends to be too large. If it's a PDF file, it's much easier for me to manage and write on because I will read your papers, write comments on them, and then return them to you. Next week, after I've got some things handed in, some things to hand back, I'll go through the system that I return papers to you. But basically, the short story is I'll create a folder for you. I will upload your graded papers and grade reports into that folder, and then you can retrieve them whenever you need to or whenever you like to. Okay, back to week 3, back to homework. So you got the written homework, the XYZ homework, and then you got next week's homework previewed here. Here's homework number 2. You can start working on it, and I'll show it after it uploads. There it is. It has to do with the things we're going to do right now, absolute value, equations, and inequalities. Okay. Also, after you hand in the homeworks, I've had some questions like this. I will put an answer right here where it says solution. I'll turn that on, and you could look at the way I did it. You could do it better. You could do it less better. I'm going to put a responsible, correct answer up there, just in case you want to say, well, how did I miss that? Or what should I have written there? That doesn't mean I'm giving you the best answer possible, shortest, most explanatory, whatever your criterion are. I'm just going to give you a legitimate answer that you could practice with and study with. Okay, I think we've covered it. So now, got 4 sections to dig into this week. We'll do 2 today and 2 next time. I know I just throw things at you at 100 miles an hour, but is there any question you want to ask just about the things we ran through there?
I have a question. Do you know the day of our exam yet?
Oh, that's a really good
Like
question.
the end of the semester exam.
Yes. So let's go to, oh, sorry, I'm going to go back to sharing. The short answer is no, not exactly, but I can give you some tips.
Okay.
So hang on, let's get to the paper. So let's go to base idea. So I've got exams listed. You see them in week 8 and week 16. Also look in the weeks 8 and the 16, they're identical. What I have on our schedule there is we're going to review and we're going to have this exam. Now, here's the thing that I don't know. When I bring you an exam for you to work on, is it going to be 3 days long, 5 days long? There's going to be a time limit on it. It's not going to be 90 minutes and you better hand it in. So I expect when we're meeting Tuesdays and Thursdays, I expect that we'll meet on Tuesday in that week, do any reviewing we want to do, answer any questions we want to answer. And then I expect, I'm still working on the parameters, that I'll do something like release the tests on a day. It could be a Wednesday. Don't hold me to this yet. And I say to you, okay, you work on these problems Wednesday, Thursday, Friday, and you hand it in, and I'm going to have to pick a deadline and a date. Deadline will be 11:59 as everything else. Date, I got to think about it. Here's the reason why I'm not being exact with you yet. There is no practical reason for me to give you an exam of 20 to 25 problems. If we were in a classroom, though, I would probably give you an exam that's about 18 to 20, 22 problems. And I would say, okay, here you are. And we got these 2 hours, and I want you to do these problems. But time just doesn't mean anything right now. And so it's very hard for me to say, okay, I'm going to do the exact same thing in the classroom. I'm going to give them 20 problems, and I'm going to turn it on at 12 noon, and I will demand it by 2 p.m. It's just not going to work because I know people have other commitments, priorities, and responsibilities. So I'm tending to think that the exam is going to be open for a couple days. And I'm tending to think that there'll be fewer problems rather than more, but that the problems will require you to do more explanation rather than calculating. So we don't just look up the answers online and stuff like that. And that's why I give you the recommended problem. So you practice doing things and explaining things. And do you understand also that on the grading, I set 50% at XYZ homework and 10% on the written homework problems to try to help you learn how to write stuff. And then the two exams together were 40%. So I see this with all my colleagues and friends, even way across other universities, colleges. We're not saying that the class ends with the big 50% final, because that is not making sense right now. So that's not a complete answer, but it's a kind of an answer. I consider the homework and the things you're doing here equally as important, maybe by your grade, slightly more important than those exams. But those exams are a chance for you to show me what you know. And when the time comes up, like a week or two before, I will be very specific. But I'm just trying to think about how things should fly right now. That's what I'm thinking.
So, does Delta close on, the 18th, that Friday,
Let
at the end
me,
of the semester?
December 13th through 19. I think the
Oh,
last day of classes is December 17.
oh, okay.
And
I was just wondering.
I can look that up exactly, and I know it's in the calendar.
It's okay. My other classes, they say, the deadline's the 17th, so, that makes sense.
Right. Now, so here's a problem for you, and that's why I appreciate you bringing the question. My class ends on the 17th, his class ends on the 17th, her class ends on the 17th. I can imagine as we get to that time that you're going to have lots of things to do in those last couple of days, as you would have lots of things to do in a regular class. So I'm going to take that into consideration and try to design something intelligent and not ridiculous.
Okay. Thank you.
So, great question. So let's think of what we're going to do here in week 8 as a trial run. We'll see how that works. We'll make adjustments if necessary.
Professor, I have a question.
Go ahead.
So regarding the homework, what exactly do you mean by explanation? Do you mean just us showing our work or us writing out in words how we're doing it?
Good. Uh, the first step was showing your work, and that's very, very important and critical. Every once in a while, you might see when I give you a question, I'll say, how do you know that this is true? And then you're going to have to write something, sentences, maybe. I never want you to write a novel. I just want you to tell me what you're doing as if you were telling your neighbor or friend what you're doing. So you want some idea of what that means, how much I should write. So what I'll do here is let me point to this recommended problem. And that's exactly why, again, I'm posting these recommended problems. So when I write this problem out, my goodness, I'm going to get used to this. Maybe this is a little more obsessive writing than you would do. But on the other hand, here's a problem. Here's a solution. I didn't over-explain it. Maybe I over-explained it a little. If you took out all these words and did all the things that I did with the numbers and letters, would I say that's correct? Yes, I would. But always be prepared to tell people why you're doing it. So the answer to your question is, what kind of level of writing are you aiming for? Not more or less than I show you here. You know, being complete, and as we go along, you'll get a feeling what it means to be complete. And that's why I want you to hand in one problem a week so I can read that and I'll write on there. Okay, good explanation. Can you show me this work here? Or you need to add some more explanation, or this is perfect, this is fine, good work. So the written homeworks were not meant to give you lots of extra practice so you could do math. The written homeworks, I wanted to give you practice just writing things neatly, nicely, so that I can say to you, yes, that's a good explanation, or you could add a little more explanation.
So, not to, I'm just trying to confirm.
Go ahead.
So, it's okay if I didn't, write out everything in words, but as long as I had everything written down, like the formulas and all that, that'd be okay?
Yes, as long and as long as they're correct, and as long as someone can follow them. So every once in a while, you might have to add some words. And here's a tiny example I'm showing on the screen here. So don't be thinking about this first assignment like, oh, I didn't do that, or oh, I didn't do that. I'm using the written homeworks just to coach you along the way. So I'm not going to be super critical. Wait and get it back. See what I write. See how it goes. And you will see exactly what we're aiming for.
Okay. The second question I had, are we going to be doing any new content on the day's review for the test?
No, that's exactly why I want those. That's why I said that. Yeah, so this is our schedule right here that I'm showing you on the web page. And I will be reviewing the sessions. And I mean, I can't, I got 7 weeks ahead of that day, right? We're not going to do everything that we just did for the last 7 weeks. I think when I say review, what I really want is that you guys have checked this out. Santa Claus made a list, checked it twice. You know what problems you need to practice. You bring them to me. There's no way on that day that you want me to roll on for 2 hours about something you already know. So you on that review day are going to bring me questions that you need double checked or demonstrated again.
Are we going to be getting any sort of study guide or anything just to know what kinds of problems are going to be on the test?
Yes and no. The recommended problems are real, in a very real sense, the study guide. Those are the problems just straight out of the book. I don't want to invent problems. I don't want to make up new crazy problems. The recommended problems are very much out of the book. The written homeworks I'm giving you are very close to the book. Oh, I got to add someone into the classroom. So those are your guides. And those are the things you're checking yourself against. I said this about the XYZ homework maybe in an earlier session. I like it, but there's no question on the test it's going to be A, B, C, D, E, check. Which one is true? It's not going to be multiple choice. It's going to be you doing a problem like you're doing on the written homework or the recommended problems. Like a homework problem, like a written homework problem. And they might look slightly different than the book. So, you know, I got questions that require you to think and explain what you're doing rather than just 2 + 3 × 17 or something. That's not a good example, but the concept. As we go along, I'm hoping you'll feel more comfortable, and you can continue to ask that question if you're still uncertain.
Okay, thanks, Professor.
No problem. And I know this takes some time as we're doing this, but you know, it's just getting going. As we get going, we're going to get very, very efficient. Okay, let me show you some interesting things here about the absolute value. And I'm going to show you some very special rules that you got to know for sure. And the book says it pretty much exactly like I'm saying it. So we're on the same page that place. And the videos I've posted, extra topics in these are also very much like this. So, but of course, as you are asking, you can bring any question you want over here and we'll write it down. So let me just remind you what absolute value means. And you may have used it many times, but I want to be sure that you have a particular vision in your mind. By using it, I mean, you know, even without any coaching, you may be able to answer these questions right here that you've seen it before. Maybe you have, maybe you haven't. If you haven't, I'm not worried. We'll show you. But if I said absolute value of 7, you would say, or type, what?
7.
Absolute value of -4?
4.
4.
And if you like, you can say or type these. I don't mind. Absolute value of 0. I'll
0.
try to get, yeah, I'll try to get tricky, but there's no trickiness I can have. Absolute value of 0 is 0. And here's what I want to make sure I take away from you. If you have this notion, sometimes people have this bad notion that absolute value makes things positive. That's not a good way to say it. It seems in the first 2 cases that it made the number positive. It was already positive, but that's okay. I made it positive again. But 0 is not a positive number. On the number line, positive to the right, negative to the left, and 0 is neither positive nor negative. So the absolute value didn't make 0 positive. So try not to say that, even though I know as you speak casually, sometimes people just say that. What it is, when someone says absolute value of 7 or absolute value of -4, they're literally measuring the distance to the center, to the origin, that this is 4 units between -4 and 0. The absolute value of -4 is 4 because that is 4 steps away from 0. You could say it like that, even though that's kind of casual. Steps away from 0. Or maybe I could say units away from 0. But I could even say this simpler in English: distance from 0. And if you start by making this your base, you'll do much better at absolute value. So for example, the absolute value of 7 is 7 because 7 is 7 units away from 0. The absolute value of 0 now makes sense. It's 0 because it's already there. It's 0 steps away from 0. And now that you know what it is, we could solve some basic equations. So if I say to you then, just with this knowledge that you just rehearsed, or maybe you already knew that explanation, if I say to you right now, and I can't remember, I think I used this on you guys earlier, I'm not a gambler, but somehow when you talk about money, people pay attention. So if I laid $100 on the table right now and told you to solve this, would anybody take me up on it? Probably. What would be the result? So there's $100 online, no pressure. But what numbers make this sentence true? You would respond what?
4 and -4.
Literally. Now, I'll only change one thing about what you said, because you said something correctly but casually in English. You said 4 and -4, and that's the way we would say it in English. But in mathematics, we're extraordinarily legalistic. And remember not yesterday, the last class session, we made a big difference between and or. I would say it like this, and this is the way you'll get used to saying it, that the numbers that make this sentence true are 4 or -4. And when you say the word or, you're saying, I acknowledge that I have 2 chances to make that sentence true. And they are not the same. If you think about a basic absolute value equation like this, and if I was on a chalkboard or a whiteboard, I would do it like this. I would put my finger over the X. Let me just put my pen over the X. Sorry. The thing under my pen, if this sentence is true, then the thing under my pen has got to be 4 or -4. The thing under my pen cannot be 6. It can't be -12. When I show this to you, and I reveal by taking off the pen, if there's a 6 under there, you're going to say, that's not true. If there's a -12 under there, you're going to say, that's not true. But if I remove my pen and there's a 4 under there, you're going to say, yeah, you're right. Or if I remove my pen and there's a -4 under there, you're going to say, yeah, you're right.
So I understand why it's +4, but in math terms, it says distance from 0. I thought distance can't be a negative number.
It isn't. But remember, you are standing right here at -4ville, and I am standing right here at 0 place. How far apart are we?
Ah, I see. Okay.
So think about that key on that word, distance. You're right. Never say absolute value is negative number. Distance cannot be a negative number. You don't have -5 miles to go on your trip. Right. So this negative sign here is not a distance. This is a number that I plug into here and get truth. Now, let me show you what a tiny walk away from that is this. Now, you may have seen this problem before, one like it, or you may have seen none like it. But let's use the same logic. Now I can actually fit my finger. Well, let's do my pinky. Now I can actually fit my pinky over that thing. What better be under my pinky? In other words, if I want this to be true, then the thing under my finger had better be a what?
7 or -7.
And that's exactly all you have to do. Think about it. The only way to make this sentence true is if, in other words, this means that either 2x minus 1 is -7, or, special word, 2x minus 1 is +7. And if 2x minus 1 is -7, you win. And if 2x minus 1 is +7, you win. But if it's anything else, you lose. Now this then looks like what? This looks like the problems we did last Thursday. Say, oh, those are two short problems. I know what to do. I heard that word last time. I know what to do. So I say, oh, let's add 1 to both sides. Let's divide both sides by 2. Let's add 1 to both sides. Let's divide both sides by 2. And now, I want you to see that it's different, right? Over here, the answer was this beautiful symmetry, 4 minus 4. Now here, I don't get the same number plus and minus. But I can check if it works. Let's try the 4. Just imagine the 4 being right here. 2 times 4 is 8. 8 minus 1 is 7. I'm good. Let's imagine the minus 3 being right here. 2 times minus 3 is negative 6. Subtract 1 is negative 7. And the absolute value of negative 7 is 7. I'm good. So this is going to be your first general rule for absolute value equations. Anytime someone tries to make you solve, and let's just say u absolute value equals a, that means either that thing there is already equal to a, or that thing right there is minus a. I wrote that exactly as I wrote it right here. Sorry, I'll move my paper up. Exactly as I wrote it here, exactly as I wrote it here. So when you see absolute value of something equals something, you just immediately snap it into 2 parts. One part looks like that, one part looks like that. If you know the rule, you win. If you forget the rule, you lose. But I'll tell you what people do. They just remember half of something, right? They say, oh yeah, 2x minus 1. Absolute value makes things positive. I bet this means 2x plus 1 equals 7. No, that's ridiculous. It never was going to turn the minus 1 into plus 1. The only way to do this is to remember that rule. Very legalistic. But on the positive side, if you remember the rule, you can't get it wrong. Now, I'll try another one with you, and I'll try to jazz it up, because then you're saying, wow, this is easy. There must be nothing to this. No. We can always make things busier. But here's the first warning I will give you. That you will meet some days evil people. So what if you met a charlatan? What if you met someone who's trying to deceive you, and they write on your paper x plus 5 equals negative 2. X plus 5 absolute value equals negative 2. Sorry, slide the paper down. Yep. So what do you say to this person? Here's your rule. Can you solve this? And that's why I always want you to think of common sense too, right? And I don't want you to say that the absolute value makes things positive, right? But I don't care what you put in there. After you take the absolute value, is it going to be equal to -2? When you think about it, say, wait a minute, I remember absolute value. Absolute value is distance from 0. Absolute value never gives me a negative number. You come back, what is he talking about? What do you do when someone gives you, you can plug numbers in here for the rest of your life. You're never going to get -2. And be careful. It's a special case. So what do you say to someone if they ask you to solve something, but it cannot be solved?
There's no solution.
Literally, that's all you say. So I want you to be aware that sometimes, and this is a funny statement to say in math, but sometimes the answer is there is no answer. So don't just say, I'll follow the rules. Do you see what happens to you if you follow the rules? If you follow the rules, you'll say, oh, that's the opposite of -2, or that is equal to -2. And then you work this out. Oh, that's -7, or x plus 5 is 2, that's -3. And then you circle these answers because, you're just following the rules, right? The answer is no, you're not following the rules. This could be a 0 on the other side, and I'll do 0 right now in just a second. But it can never be negative right there, or else you won't be able to use this rule. Now that kind of begs the question, doesn't it? So what if I put a 0 there? Would that also be impossible? Let's think about it. If I put a 0 there, can you give me any winners? I don't mind how you do it, but is there any number you can imagine that would give me a true statement? What do you suggest? Well, you go back to the first paper I said, there was a number that had absolute value of 0. Which number has an absolute value of 0? Oh, 0 does, because it's 0 units away from the origin. So this gives you a way to solve this problem. Could you solve this problem? Yes. If x plus 5 is 0, then the absolute value of x plus 5 will also be 0, 2. And then you know how to solve this x plus 5. So there is a number that works. I think -5 works.
So if it's equal to 0, then there would just be one solution?
In this case, yes. The problems we're going to do today, yes. And that's an important thing that you pointed out. So you can have no answers. You can have one answer. And then on the previous page, you can have 2 answers. But I want to say something to you because we're about to do another problem. If this was a less than or greater than, then you can imagine from what we did Thursday that there could be many, many, many answers, a whole interval. So don't just say 0, 1, and 2. But in this case, if you have this here, there's only one answer. Now, if I put something fancier inside here, I could imagine that there would be more than one answer. But that is not what we're doing in the section. And we might talk about it later, but it's not today. So don't worry about it yet. Right now, if it's equal to 0, the odds are you're going to have one answer. Okay, let me try one more on you before we go to another rule, and then shortly we'll take a break. So I'm sitting here thinking, and I also have the book in front of me. You might have the book in front of you. Let's get weird. So this is problem 49. So what you're thinking right now, section 2.6, what you're thinking right now is, Oh, equal sign, absolute value. This is easy. I don't have a problem with that. But remember that there may be other things that you have to do on top of it. So I'm just copying this problem out of the book. So this has absolute value, has equal sign, but there's still, this looks busier than the ones we've done so far. So here I have to give you another rule. This rule that I gave you right here is all you need. But before you can use this rule, what? It better look like this. In other words, comparing it to this problem right here, I cannot use this rule. This is not ready to use that rule. In other words, sometimes you have to do some prep before you use the rule. Now, the prep here that I got to do is not crazy. It's not too difficult. But what I want to say is I have to isolate the absolute value. So I will add 2 to both sides. Now I have the absolute value of this thing is 5. Now, if I have the absolute value on the right side, that doesn't bother me. If you want me to switch it, I'll switch it, but I'm going to take it the way it's written. And now I can tell you what it means. For all the money, for all the marbles, whatever you want to say, there's only 2 ways I could win right now. Either this stuff under here is 5 already, sorry, or this stuff is minus 5. So that's all I'm going to do. I'm just going to write that. Either 5 minus 2/3 A is minus 5, and I win, or 5 minus 2/3 A is 5, in which case I will win. Now I've got it down to smaller problems. Okay, there's a fraction here, but I'll survive. Let's do this. Subtract 5 from both sides. And we met this the other day. I could say divide by minus 2/3. I could say multiply by minus 3. And then after I cancel, divide by 2. As long as you get to the right place, I don't mind whether you do it in 1 steps or 2 steps. Over here, I'll do the same. Let's subtract 5 from both sides. Well, that's nice. If I have minus 2/3 times A equals 0, there's only one way that could happen. Now, I could multiply by negative 3/2 if you want to see it all legal-like. Multiplying by negative 3/2 will destroy this fraction with 1 stroke. But it doesn't matter how I say it. 0 times minus 3/2 is 0. The only way for this statement to be true is if A is 0. Don't forget the or, because this means you have 2 numbers that could get you the $1 million. Either 0 or 15. We could try them. If you put 0 in here, this automatically becomes a 5. Absolute value of 5 is 5. Minus 2 plus 5 is 3. Winner. I'm remembering who was the Hollywood actor who got in trouble for saying winning? Anybody know that one? That may have been like 3 or 4 years ago. And he was just getting in all kinds of trouble because he was in rehab and stuff like that. And he was doing interviews and he was saying to people, get off my back, get off my back. And say, I'm an actor, I've got a lot of money. Maybe you never saw that. Like maybe 3 or 4 years ago. That was his little silly catchphrase, winning. Let's put 15 in here. If you know the name, type it in the chat. you would recognize the name if I told you, because you'll see it on TV and reruns right now. Movie actor, well-known movie actor. Okay, A equals 15. 2/3 of 15 is 10, minus 10. 5 minus 10 is -5. -5, absolute value becomes 5. 5 minus 2 is 3. These are both winning. It is Charlie Sheen. That's right. I think we spell it with CH. For bonus points, he's in 2.5 Men. What movie did he get a lot of attention for? Okay, on to the next problem. Let me do one more problem, then we'll take a break. That was kind of a comedy. One more problem, just to tell you, you want to be careful. That the rule's always going to do it for you. The rule's always going to work as long as you prep things correctly before you execute the rule. So I'm trying to look for an interesting problem. Don't see one yet, but let's try. Oh, go ahead. If you have a question, go ahead. You can say it or type it. What are you working on, Benito? In case your microphone is stuck, then you can unmute it. Okay, good. That's a good question. I had minus 2/3 A is equal to, and I'll hit your mic there. And what is it equal to minus 10? And that was right here. Now you're asking a really good question, because how do I get to my A? Do you know that there are 3 things between me and the A right now? 3 things that I got to kill. I am multiplying by 2, I got to get rid of that. I'm dividing by 3, I got to get rid of that. I am multiplying by -1, and I have to get rid of that. I could get rid of all 3 things in one stroke if I multiplied by -3/2. But then I have to do it to the other side. Multiplying by minus times minus will make this plus. Multiplying by 3, dividing by 3 will cancel that out. Multiplying by 2, dividing by 2 will cancel that out. And now I have A all by itself. This will be 30 over 2 is 15. That's the way I did it on the right. I multiplied both sides by -3/2, so you can do it that way. On the other side, I said, oh, let me multiply both sides by -3 to get rid of that minus and 3. Now I just have a 2. Now I will divide both sides by 2. So what I said when I was doing that, I said, like, if you want to do it in 2 steps, if you want to do it in 1 step, as long as you do it correctly, we're okay with that. But I was just showing you 2 different ways to get to the end there. That was a little shorter. If you don't like walking and chewing gum at the same time, then just do it in 2 steps or 3 steps. So just work in the algebra right there. Let's say I'm getting -3 times x minus 2 stop are going to be 4. Okay, let's do this, then we'll take a break. Because I'm trying to make it busier. You know, like, how could I really test you? A lot of minus signs, stuff like that. Okay, so according to the last problem, you just learned, oh, I'm not ready to do anything yet. I got to isolate the absolute value. So let's subtract 7 from both sides. Now I got -21. It's minus 3 times x minus 2. Now let's not jump to any conclusions. You got the absolute value. You got a negative number over here. So you're going to say, impossible, no solution. But that's wrong. You still have not isolated the absolute value. What do you mean? It's right here. No, no, no. There's a minus 3 attached to it. And you cannot do the rule till you get rid of the minus 3. Now could you do it? So say, think about this. If I laid $100 on the table and said, I want you to do that, or if I laid $100 on the table and say, I want you to do that, which one are you going to choose? You're going to choose that second one. Looks easier. But this is the same thing. I just had to prep this. I have to prepare this first. Okay, now we're going to finish. If the absolute value of x minus 2 is 7, then I've only got 2 chances to win. Either x minus 2 is minus 7 or x minus 2 is 7. That's all I have to do is obey the rule. Add 2. Either x minus 2 is minus 5. I'm sorry, either x is minus 5 or x is 9. I can see that works right here, but this is where I need to check. Let's take the 9 up here. Stick a 9 in here. This becomes 7. Absolute value of 7 is 7. 3 times 7 is 21. What's 7 minus 21? Negative 14. Got it. Let's take the negative 5 up here. Negative 7. Absolute value 7. 3 times 7, 21. 7 minus 21 is minus 14. Got it. There's the answer. These ones. Say this or this. I know there's a strong tendency to say and right here, but don't practice saying or and say to yourself in your mind, I've got 2 chances to win. 2 chances to win. It's either this or it's that. Okay. That is the first basic rule. And if you believe that and are willing to follow it in that way, I've got 2 more rules, but they'll make much more sense now that you think like that. Let's just let you stretch your legs and hang out for a second. I got 104. I'm just going to mute my microphone, stretch my legs, and come back at 109. Now, you know, if you got other questions, type them in the chat window. We'll come back and we'll answer them when we come back. So take a break for a second. Okay, we're back. That practice we just did was section 2.6. So you have everything you need right there. And we're going to do 2.7 now. And then you could do the first half of the next homework. You could do the solving of the absolute value problems on the next homework. What we're going to add to it on Thursday is I'll show you how to graph things, or what does it mean to graph these. And that'll make it even make more sense to you. So Charlie Sheen, anybody go look up the movie? Major League? Just a silly, funny baseball movie. He was the crazy young pitcher in Major League and Major League 2. And it also had Wesley Snipes in it. So I just like movies. At least most movies. Okay. Now let's take the next step. And if you're willing to keep thinking like we just did, it's not a big step. But what would happen if you had an absolute value and an inequality? You say, I got this. I know what this means. X is -4 or X is 4. That's a very simple example. Now, let's take a step over here. And let's say, what would it mean if I said absolute value of X is bigger than 4? Or bigger than or equal to, either way. But let's always think about the same game. And I'm not talking about money. I'm not talking about gambling. I'm talking about getting something correct. When I say, you win, okay, you win $100 or you win because you got the problem correct. I'm trying to fix it so that you win by getting the problem correct. But you could use the same logic here. You're easily, let's look at a picture. If I laid $100 on the table again, and I said, tell me some numbers that make this true. Tell me some winning numbers. It wouldn't be that hard. Give me a couple numbers that win. You can type them or say them, either way. If you were to give me a number win, you start saying stuff like 5. Oh, okay. Benito was thinking exactly the same number. 5 is a winner. 6 is a winner. 7, 8, 9, 10 is a winner. Is 4 a winner? I have to think about that. Yes or no? Legally, no, you're right. Because 4, absolute value is 4, and that does not beat 4. 4 just ties 4. But you know how we're going to draw that from last time. I'm going to say, can't use 4, but I can use everything bigger. Of course, the moment I say that, you know that that's not all the answers. What other numbers would win? And it's kind of like, I know you know it, but say it or type it anyway. 0 is not going to win. -5 would win. That's correct. And then you start to pile on. -6, -7, -8, -9. You start going to the left. You'd still have the same problem about -4. You better be careful at -4. -4 would be absolute value, make it 4, and 4 is not right. It will not work. So I cannot use 4, but I can use everything less than. That's how I would draw it. And the moment I draw it, you say again, I have 2 chances to win. Or. And this is described in math language as x is less than -4.
So does 4 on the positive side work or no?
No, it does not. And that's why I got these round bracket. Remember the style we were using last time? If I want to say less than or equal to, greater than or equal to, I got to use hard square bracket or a solid dot. But if I say less than or greater than, I indicate that I'm not using 4 by doing a soft bracket or an open circle.
Oh, okay. So it starts at 4, -4, but it just doesn't include 4, -4.
Good, correct. Or how about try this word on for size? The boundary is at 4 and -4, so to speak. Here the answer is 4 and -4, and the answer looks like this, except it's kind of boring. So I'm not going to make you graph this. And this is similar. I've got 2 chances to win, but now I got lots and lots of numbers that win. So here's a new rule. And now you can probably sense the rule. When the absolute value is greater than something, absolute value of u, something, this u could be short, like an x, or it could be ugly, like 7x minus 27 times x plus 5, anything. When absolute value is greater than something.
Professor, could you move the paper up a little bit?
Very good. Yes, thank you.
Thank you.
That means either, let's say it logically in English. If I told you the absolute value of u is bigger than a is a positive number, that means either that thing inside there is already bigger than a by itself, already, like the numbers 5, 6, 7, 8, 9, 10. Or what's the other side? It is less than the opposite of a. And that's what I wrote there. Either it's way bigger or it's way on the other side smaller. Let's test that out when I got something in there that's more complicated. And while we're at it, I'll toss in an equal sign to make it busier. And I'll rearrange the inside a little bit and see if that distracts you. I got to move the paper down. I almost am tempted, maybe we'll try it someday, that I'm like stand at the whiteboard, because I did set up the whiteboard and I use it for videos if you watch some of my videos. But I don't think I want to just stand at the whiteboard and stare at the wall. Either way, I don't really see you. But I think at least here I'm paying attention, seeing if you're typing something, asking a question. Anyway, let's solve. I got to use the rule. Let me get the rule over here. Only way to do this right is to use the rule. So I pretend that this thing inside here is the u, and I pretend that the 5 is the a. And the fact that there's an equal sign there too, that doesn't change how the rule works. So what does this mean? Let's think about this. Either this stuff in here is already bigger than 5 or equal to it. 5, 6, 7, 8, 9, 10, and so on. So either that stuff is already bigger than or equal to 5. Or what's the other way to win? This stuff could be way down on the other side. Less than or equal to -5. Do you see how you put a minus sign in front of there and you change that sign? Direction, you change the direction of the inequality. And that's different from the first rule because the first rule had equation, not inequality. So either this stuff is already big enough, like 6, 7, 8, 9, 10, even 5 works. If that stuff in there is 5, I'm happy. Because 5 absolute value is 5, and 5 is bigger than or equal to 5. You notice the power of the word or, bigger than or equal to. The other option, or, is that this stuff is less than -5. It's way down the other side. And let me tell you how this works. If you follow the rule and decode this, now I am seriously betting on you. I mean, you got to do 2 problems, but they're easier than they were a second ago. And we did these something like these last time. Go ahead. Or if you had a question.
One question. So
Good.
does the rules that we set last time still apply? Like if you divide by negative, the sign still changes?
Yes, and that's why I inserted that to see if I could catch anybody. I still got to obey when I clean this up. I still got to obey that if I multiply or divide by a negative number, I reverse this again. So that's the thing that starts to wear on people about math. They say, I can do that rule. I can do that. But then they start to realize, wait a minute, I got to follow the rules he taught me today and the rules he taught me last time and the rules he taught me last time. In other words, they start to pile on, right? So just, you got to be patient when you do that. Let's do both of these. Subtract 7, subtract 7. I got minus 2x is less than or equal to minus 12. Subtract 7, subtract 7. Minus 2x is greater than or equal to -2. Doesn't hurt to keep saying or, just to remind yourself. Now, I will divide both sides by -2. That will become x. That will become what? Positive 6 when I divide by -2 on both sides. But this sign will what? Reverse. Over here, I didn't write it in the last thing, but let me write it now. I will divide by -2. I will divide by -2, but the moment I do that, I have to reverse that sign. It is very easy to forget that, so be careful. Now, I got my x less than or equal to 1. And still got an or. Do you want to practice drawing it? Do you want to practice that interval notation from last time? It can't hurt, and that's probably how he's writing the answer in the book, right? Here's a 6. And notice the equal sign that we just dragged through the problem. Now 6 is a winner, solid dot, or hard bracket. Everything bigger than or equal to 6. Over here, 1 is a winner. And everything less than or equal to 1, if you want me to write it in the fancy interval notation, -infinity to 1, hard bracket, or what's called union, hard bracket, 6 forever to the right, infinity. Okay. Got it. Okay. So what I'm trying to make you feel good about is if you follow the rule, which you must remember, then you just do pretty much the same steps as we did earlier today. You got to remember that reversing the inequality when you multiply or divide by a negative number. But it's very doable. Okay, let's try it again. Try it the other way. So, new problem. Good. The answer is yes. And I want to make it really clear for everybody who's reading that. What you mean is the rounded parentheses, because sometimes people call these square parentheses. That's right. Never put a square parentheses on infinity or minus infinity. Very good. Never say minus infinity like that or infinity like that. Never. Very good. Because the square bracket means you're using the number 6. And if you put a square bracket on infinity, then you're using the number infinity. And then I'm going to ask you, what's the number infinity? There is no number infinity. Infinity is just a place. It means at the end of the road, but you never get there. Infinity just means you never stop walking. Let's try it the other way. What if I said the absolute value of x is less than 4? Okay, now we're going to have to be more careful. So the first 2 rules I've shown you are pretty mellow and almost alike, and that they gave you 2 chances to win. And so sometimes people remember it like that. But then they see this rule, which is slightly different, and they start to mix them up. That's the greatest danger. That you take the 3 rules I'm going to give you today and you start mixing them up. That's when people get wrong. So before I say the rule, let's do it, possibly the easy way. Can you just name numbers that win? If I put money down, I'm sure you could name numbers that would make this sentence true. Such as?
5.
Would 5 make it true? Now remember,
Never mind. Sorry, wrong side.
good. But on the other hand, I'll say this to you. Finding something that doesn't work is sometimes as good as something that does work because they give you the tip, off. What? So since 5 does not work, because absolute value of 5 is 5, 5 does not be less than 4. But now you can start naming the ones that do work. 3, exactly. Any others? -3, you are right. Let's do the difficult case right now. Does 4 work? Yes or no?
No.
Legally, no. Now, if there was an equal sign here, you'd have to say yes. But there is no equal sign, so legally 4 does not work. Let me put an open dot this time just to practice that. So now 4 does not work, but 3 works, 2 works, 1 works, 0 works, -1, -2, -3. So I just keep going forever, right? That's right. Then you say to yourself, whoa, no, you can't go on forever because you get down here to -5. -5 does not work. -10 does not work. -100 does not work. In fact, you already sense where the border is. -4 would not work because 4 is not less than 4. And in fact, at that moment, I have to stop. Or if you like the bracket, round bracket, hard bracket notation, you could say it like that. Or you could say it like this. Or you could say it like this. Those are all the different ways you could write that. But they all say the same thing. The winners are the people who are kind of small, less than 4 units away from the origin. All the people that are less than 4 units away from the origin. Now, I want you to review these 3 answers because this is how you're going to remember them. When you said equals 4, then the answer was right there, dot, dot. When you said greater than 4, then the answer was right here. I'm just making a sketch. Outside. I think of the word outside. I think of the word border. Here I think of the word inside or between. And so these are the 3 rules that you got to keep straight. And these 2 have 2 chances to win. But this only has 1 chance to win. You got to be in there and nothing else. So now you're ready for the final rule.
If you were to connect like 1x equals 4, like that would mean that you would be saying if you did that, that'd be everything in between, but that's why you don't put that line, the line on the graph to connect
Okay.
the
Are you
1x
thinking left, right, or middle?
middle.
Okay, what do you want me to do? Oh, I don't connect them. You're right. I
Right.
will not connect these because I am not using these numbers in here. That's right.
Okay.
I'm
Okay.
only
I just want to
using,
make sure.
right. Good question. I'm only using those 2 numbers.
Okay. Thank you.
No problem. So this is the rule for absolute value less than something. When you have the absolute value less than some number, some positive number, could be less than or equal to, then the rule looks the same. That means, and if you want to say that word, go ahead. It means between. It means that your thing is trapped between minus A and A. And we did this at the very end last time, kind of a triple inequality or a compound inequality. The author has a strange word. He calls it a continued inequality. Oh, that's okay. It's his book. In other words, he has an inequality, then he continues it on again. This rule is not harder to remember. Let me get them all 3 on the same screen. Let me get them all 3 on the same screen if I can. Yes, I can if I fold the papers. There's a lot of extra work. Here are the 3 rules. And the danger on these is not that you don't know how to use them or can't use them. The danger is you mix them up. And you do this rule when you do that problem, or you do that rule when you do this problem. The challenge for you today, the work for you, the hard work for you is, can you remember them and use the right one at the right time? And at first you say, well, of course I can. Why are you, that's a silly question. Of course I can. Yeah, but when you're out there in the heat of the battle, you will make a mistake once in a while, as everyone does, as I do. Let's do a test. So I want you to solve. Now here's straightforward. I won't try to trick you on this one, but on the next one, I'll try to trick you. Let's try to have you solve 2x minus 3 is less than 7. Now notice today also, I'm not going deep into fractions. If you look in the book, and he's got some problems in there, he's got some fractions. But this is just a general rule of thumb. If you're trying to explain something to someone, don't make it worse than it needs to be while you're explaining it. you need to be able to do these problems even if they have fractions in them. But first, I'm just wanting to test you on mellow problems. So what does this mean? If you're so bold that you can speak it, because it's probably hard to type into the chat box, speak it. What do I have to write?
Would it be -7 is less than 2x minus 3, which is less than -7 or +7?
+7. Okay. Yeah, it's between those two numbers. It's between minus a, and a has to be a positive number. Then you can do this. So between. Now we have to remember what we did last time, triple inequality, but we're doing well, and we're doing well on time. I'm going to be fine as long as I do the triple golden rule. Add 3, add 3, add 3. Do the same thing to each piece. I don't want to say do the same thing to both sides, because there's not both sides. Do the same thing to each part. What do I got? -4, less than 2x, less than 4. I wasn't trying to make a crazy problem. Next problem, I'll make a little bit crazier. Now, next up, I want to know what x is. I will divide everybody by 2. Divide by 2, divide by 2, divide by 2. -2 is less than x, is less than 2. And the answer, if I was to draw it, would just be from -2 to 2 and no more. Soft brackets, no equal signs.
Professor, I think you made a mistake.
Which is quite possible. Go ahead.
At the top, you
Yeah.
added 3 to 7, and you got 4 at the next part.
Exactly. Perfect. It's strange how you will run through something that'll be obvious to everyone but you. I was in a hurry. 7 plus 3 is not 4, it is 10. Now here's a tip too. Don't erase the whole thing. And if I was using a pencil, you could just cross it out nicely and write a 10 there. You cross this out nicely, write a 5 there. You can erase the bad stuff if you want to. Okay, I'm gonna have to make that a 5. Now it looks terrible, lopsided, but I'm gonna take it that way. That's the answer. Does 5 work? Better not, or else I've done something wrong. Let's put 5 in here. 10 minus 3 is 7. That's why 5 doesn't work, because it makes a 7. And 7 is not less than 7. But every other number in here works. -2 apparently makes this equal to 7 also. -7, absolute value, which would be 7. Okay. You got the name of the game. Now let me try to challenge you, because I always got to use common sense. What if I said 5 minus 3x is greater than or equal to -2? Now you're going after your rules. You're going back on your paper. You're going to look at the rules. Which rule should I use here? But never forget to use common sense. And this is a little bit like I showed you earlier. And you say, oh, it's one of those no solution problems. Not exactly. But something bad is happening. The absolute value never produces negative numbers. It could produce a 0, and you've seen it. But what's the very lowest number I could have over here on the left side? I don't care what you put in there. This thing right here is what? Always greater than equal to 0. Right? You can plot numbers in here all day long if you want, but the absolute value sign is going to give you an answer that's what? Always greater than equal to 0, right? So in that case, if someone asks you to solve this, solve means tell me the numbers that work. Solve means tell me the winners. Then what is the answer? What are the winners? You certainly don't want to say no solution. Just put a 0 in there. 5 minus 0, absolute value is 5. Is 5 greater than or equal to minus 2? Yes. So 0 works. And what I'm trying to convince you of is that any number you put in there will always give you back a positive number, maybe 0. So what are you saying to yourself? What numbers work?
All real numbers?
That's the only way you can say it. You could say everything works, which is a little bit too casual for a math class. So if you want to be really formal and correct, that's exactly what you say. All numbers. And mathematicians be even more careful and say all real numbers. So I have a video on the website that I flashed at you earlier that I want you to remember and go look up later. It says absolute value, all or nothing. I've shown you a problem where nothing works, and now I've shown you a problem where everything works. Here was the problem a second ago where nothing works. Why does nothing work? Because the absolute value will never be -2. Never, ever. Why does everything work? Because the absolute value will always beat -2. Always. Okay,
So how would this just be different from any other regular problem then?
a good question. I did not have to appeal to the rules. Now, I don't know if that's comforting or non-comforting, but I didn't write down the this means this or this. This means between. This means whatever. That's what I mean by if you know your common sense rules, then, and here's why this is important. Because when I told you those rules, I said, well, this number has to be greater than 0, or else this rule doesn't make sense. What happens if this number is less than 0? Then I have no answer. What happens if this number is equal to 0? If you saw that, if you saw the number on this side be 0, are there any numbers that could make this work? And the problem is, to be less than 0 means to be negative, and this puppy is never negative. I don't care what you stick in there. Never negative. So the answer is that there's no solution to that problem. And the answer to your question is, what makes this different than the other problems? I did not use one of the rules. I did not use one of the 3 rules. I used my knowledge of absolute value, or if you like to say it this way, which is kind of dangerous, I used common sense. Problem with common sense is it's not common. I forgot who said that. Is that Benjamin Franklin or something? You guys are online, Google something. Somebody, actually, that's a famous saying. The problem with common sense is that it's not common. In other words, people don't got common sense. Maybe it'd be better for me to say, I used my knowledge of the absolute value. Absolute value is never negative, so there's nothing that could make this true. I'm not trying to trick you, and tricking is a bad word. I'm just showing you problems, but let me try this one. What would you do if I said this? Sorry, pull down the paper. And you don't have to tell me the answer because maybe you can't see the answer immediately, but if you're willing to talk it out, talk me through it, or what should I do, or what should I say? You were very close. There is one number that fails, which is kind of funny.
Fails would be 0, wouldn't it?
Good, you're half step away from it. Failure would mean what is 0? You're on top of it. Your first reaction, though, is to say, everything works.
All real numbers except 0.
Almost. And this is like, you've heard this saying, if there's a snake, it'd bite you. But you're on the right track. Let's talk it through. So your first reaction is to say, everything works. What's your problem? Everything works. But then in my back of my mind, I remember, which is what you're thinking when you say that, but you got to change your saying. I remember, no, wait a minute. If that stuff inside is 0, I lose. So you said 0 doesn't work. I want you to change it just slightly. 5x minus 1 equals 0 does not work. Do you realize this would be the only time you would lose? And that's kind of funny. That here's a problem that works for every single number except 1. But now that I've written this down, you can tell me what is the number that fails. Let's find the failure. Let's find the bad number.
It'd be 1/5.
That's right. When I add, I was about to say minus 1/5. When I add, I get a 1. So I want you to be careful when you just read these. Before you go apply the rule, you say, what is this telling me? What does this mean? I'm going to do one more problem, not where I'm trying to trick you, but so now this is really interesting. How do I say everything works except 1/5? I could say it like this. I could say, start at 1/5, don't include 1/5 and go all the way out. Start at 1/5, don't include 1/5 and go all the way down. I could say x is not 1/5. That's fair. I could say from minus infinity to 1/5 or from 1/5 to infinity. All those are legitimate. I'm trying to tell you there's only one number that fails. Everything works except that number. Some people would say it like this. All real numbers except 1/5. And that would be legitimate. Now remember our saying from last time, if they told me to graph it, then all real numbers except 1/5 is not legitimate. I mean, you got the right answer, but they want the graph. If they want interval notation, then this, x is not equal to 1/5. That's not legitimate. It's the right answer, but it's not what they asked for. So you always give people what they ask for, right? When you meet difficult people, what do you do? And I don't mind if you shout it out. You're not going to offend me. What, when someone's having a bad day, when you meet a difficult person on the street, what do you do? As long as it doesn't damage you, you just let them be. You just give them what they want. So if someone says, solve this and write the answer in interval notation, you write the answer in interval notation. If it says, solve this and graph it, you graph it. If they don't make any demand on you, then you can write the answer any way you want, as long as it's correct. Okay, one more problem. And this time I will bring out fractions, make sure that we're okay. And I will bring out more than one fraction. So as I scan the problems in the book today, I did not see any problem as nasty as this one. Maybe you'll find one. But this would be like a challenge question. But you can do it. So just one at a time. I don't mind if you type it or talk it, but just give me the steps one at a time. What is the first thing I should do so that I can apply them?
Subtract 1 from each side. Well, 3 minus 2 is 1, right? And then
Okay, good. I'm glad you said that, because that's something that's a trap in a way. That is a trap.
oh, you have to divide by the -2.
Right. This is not 3 minus 2. This 2 belongs to these people. Yeah, multiplying. So, and Benito mentioned it. You do subtract. You subtract 3 from both sides. Yeah, don't. That is a very strong temptation to say, oh, I know, 1. No, that 3 is a single. This 2 is married. This 2 is married to this. And so the 3 and the 2 don't mix. Okay, subtract 3, and now I got I think I gave you sports analogies in earlier sessions. Whoops. Can't type and can't write and talk at the same time. Okay, -2 times absolute value of 1/3 x minus 5 is greater than or equal to 3. Next step. Divide both sides by -2. You are absolutely right, as long as what?
You change the sign.
Reverse the inequality. That's right. Okay, now this cancels out the -2. Now I'm down to this. It's not what I intended, but I wrote the problem, so I'm going to have to take it. What's the next step?
Would that be the compound inequality rule?
It would, if that was a positive number.
So it's no solutions.
Right. Yeah, and I wished, I didn't mean this to be negative, but I got to take it because I wrote the problem, right? No, I'm not going to do anything else. I'm done. It is impossible for this to be less than or equal to a negative number. Don't overlook that if you see that in a problem. So I just say no solution. You sports people in the audience, do you know who Jimmy Johnson is?
NASCAR.
You are correct, but I'm thinking of another Jimmy Johnson. There is a driver, Jimmy Johnson. Yes. Does anybody know another Jimmy Johnson? And it would be older. And so I understand if you never saw this person in the sport, but you see him commentating. Jimmy Johnson, football coach, NFL coach. NFL coach, famous for coaching the Cowboys. Has anybody heard that, Jimmy Johnson? You see him commenting on games sometimes. Nowadays, he's older. And yeah, let me give you a sports analogy again. Now, Jimmy Johnson, I hate the Cowboys. I hate the Cowboys. Because when I was growing up, they always beat up on my beloved Los Angeles Rams. But Jimmy Johnson was a Cowboys coach, and the Cowboys had great teams, 70s, even into the 80s. Roger Staubach, Tony Dorsett, great players. But then, as all teams do, you're great, and then you fall on hard times because you don't got the draft picks. So Cowboys fell on hard times for a while after those great years. Jimmy Johnson came into the Cowboys when they had like won 2 games. And the next year they won, 8. The next year they went to the playoffs. His 3rd year they won the Super Bowl. And they didn't have any stars. Of course, you develop stars, but who are stars except players that just do the job at the time they're supposed to do the job, right? They weren't stars when Jimmy Johnson took over. Maybe I'm spelling that badly. I don't know. I'm not a great speller. But Jimmy Johnson took the Cowboys from like 2-14 to, good winning record, Super Bowl victory. I forgot who they were playing in that Super Bowl. But before that kickoff in the Super Bowl, and remember, he had a locker room full of people that hadn't been at the Super Bowl. Maybe some of them were veterans, right? But he had a locker room full of people that had never been at the Super Bowl. Kind of, mostly. So he took a 2x4. He took a regular 2x4. He laid it on the locker room floor. And he said to each player, you walk across this 2x4 right now. And the players got up, step, walked across the 2x4. And, they're looking at him funny. Of course, they're looking at him funny. And he said, okay, you walked across that 2x4. It's no big deal, right? Now let me put that 2x4 between 2 buildings, 50 feet in the air. Would you do the same thing? And he said to them, and I'm saying this to you right now, when you're practicing the rules, when someone's here next to you helping you, it seems like the most natural, simplest thing in the world. But he said to them, we're going to go out on that field, and you got the cameras, and you got the screaming, and you got the excitement, and you got the adrenaline, and you can forget what you're supposed to do. And all you got to do is what we practiced. That's all you got to do. Now, what are coaches? Coaches are people that are great motivators. I'm not a great motivator, but if you want to be a coach, you got to be knowledgeable. I suppose you got to be a little bit of a motivator. I'm not trying to trick you or motivate you. I'm just saying, while we're here together, it looks simple. Can you do it when the lights and the cameras are on? Can you do it when you're by yourself? Can you do it when the game is on the line? Okay? I know you can, and you can, but it takes practice. That's all he said to them. All you got to do is what we practiced. But you got to practice. Okay. Thank you for being patient for the extra 3-minute sports analogy. You guys relax. I'll see you on Thursday. Finish up the 2 homeworks. Send me questions while you're working if you need something, and I'll get this recording posted and notes posted. So you guys have a great day.
Professor, before we go, I have one
Yeah,
question.
go ahead.
So for the last problem, let's say you didn't catch the trick on time. Is there a way to check it, like through actually solving it out?
If you use the rules, would you still survive? That's what you're asking. And the problem is, yes, but somewhere you got to get woke. Somewhere you got to wake up. Let's use the rules here. So 1/3, so I can answer this question quickly, but maybe next day we'll answer it again. And what I got to use is the rule, which is 1/3 x minus 5 is what? Less than or equal to minus 3/2 and greater than or equal to 3/2. Because I'm supposed to put minus a here and a here. And if a is minus 3/2, your question is, would I still survive? And the answer is you would, but you'd have to someday realize, wait a minute, I'm about to write down 3/2 is less than negative 3/2. I must be crazy. See, what did you just write down here? You just wrote down 3/2 is less than or equal to stuff, which is less than or equal to minus 3/2. That is impossible. And then you better come back to here. So the answer to your question is, if you use the rules, would you have survived? Yes, if you saw the problem. So in a way, it's not just rules, or you'd be a machine that just followed the rules. No, you got to use the rules and you got to see what they mean. So it's kind of a half yes, half no. Yes, you might survive if you saw that what you were writing down was silly, was impossible. We could come back to that and try that again, because that is going to be a theme in other places. Don't just blindly follow rules. You got to.
I think I understand. Thanks, Professor.
Yeah, you got to. But it's a great question. Okay, you guys go have fun. Shoot me some other questions an email if you need anything. Have a good day.